Our other topic in this section dealing with statistics is just mean, median, and mode. And I know most of you are probably familiar with these concepts, and what they're really known as collectively is they're known as measures of central tendency. And the key word there is central, meaning center, right? So what mean, median, and mode are is they're really different ways of talking about the center of a set of data. So the mean is the one that you usually think of as the average. So how do you find a mean? You know, you add them up, right? Remember we had said that sigma means add up. So you add up all the x values, which are all the pieces of data, and then you divide by how many there are, which we had called n before, right? The total number of pieces of data was called n, and what we call the mean of a set of data is this x bar, right? That's the way you would read that. When you see this, you would say x bar, and x bar really just means the mean of a sample of data. All right, and the median is the value that lies in the middle of a data set when it's ordered, right? And you can order it either from least to greatest or greatest to least. The way that you order it doesn't matter. The middle will still be the middle. So the median is going to be the one that lies in the middle. How would you find the median? You would arrange the data from low to high, or from high to low, like I say. If there's an odd number of entries in the data, the median is the middle data entry. And if there's an even number of entries, the median is actually going to be the mean of the two middle data entries, right? Of the two that are closest to the middle. All right. And actually, another thing that's important to keep in mind is median is also known as the 50th percentile. You may have heard these phrases, percentiles, before, like, oh, I'm in the 95th percentile, or oh, I'm in the 60th percentile. 50th percentile just means there's 50% of the data greater than the median, and there's 50% of the data less than the median, right? And that kind of plays into the idea that it's in the middle, right? So that's why it's known as the 50th percentile. So the median is the middle, or the 50th percentile, and then the mode is the easiest one probably to figure out. It's just the entry that occurs with the greatest frequency. So one thing to keep in mind though is that a mean and a median will always exist, but a mode may not exist, or there could be multiple modes. So there'll be one mean and one median, but the mode may not exist at all, or there could be multiple modes. All right. So when would a mode not exist? If everything just occurred one time, right? If every piece of data occurred one time exactly, then there'd be no mode. But there could be multiple modes if two different pieces of data had the same frequency. So we'll go back to our example with the cereals, right? So if we were going to use sugar and find the mean of sugar grams in all those cereals, what would we do? We would look down here, we just add up all those values, and then we divide by 15. There's actually a quicker way to do this. If we look at our original frequency table for sugar, what we can do is, rather than add them all up individually, we can see there were two zeros. So what we could do is we could think of this as 2 times 0. There was 1 1, so that's 1 times 1. There was 1 2, so that's 1 times 2. There were 4 3s, so that's 4 times 3. There was 1 4. There was 3 5s, and there were 3 6s. Now you might say, and you probably be right in this case, well, that didn't even really save me any time. And you're right, it didn't, because there was no frequency that was like, 6 or 7 or 8 or anything like that. But when there's less values and they have greater frequencies, then it's probably worthwhile to do this kind of thing, right? So you would multiply the frequency by the actual value. So 2 times 0, 1 times 1, 1 times 2, and so on and so forth. And then that would be an easier way to add them up. And then when you do that, you would end up with 42. And then 42 divided by 15 is 2.8. So the mean grams of sugar is 2.8. And then the median, well, the median, again, I can look at my frequency table to get it, and I can realize, hey, well, if there's 15 entries, the middle one is going to be the eighth one. So the eighth entry is the middle, right? Because there'd be 7 less than it, and there'd be 7 greater than it. So 7 plus 7 plus 1 gives me the 15th. So I'm looking for the eighth entry from least to greatest. So if I start looking down my frequency list, well, there were 2 there. So 1 and 2 are there. Then the third one is here. Then the fourth one is there. then the 5th, 6th, 7th, and 8th are all here. So the 8th entry is actually going to be 3. So the median is 3, and I should probably label these in grams, right? 2.8 grams was the mean, 3 grams is the median. And actually now the mode, again, when I have my frequency table here, again, it's easy to see which one has the highest frequency. Well, once again, it's 3. So the mode is 3 grams. All right. So in this case, they were all very close, right? The mean was 2.8 grams, the median was 3 grams, and the mode was 3 grams. All right. And then they want me to do the same thing with fat. So that would be my frequency table for fat. And with fat, it's going to be a little bit easier because there's only 4 different values, 0 through 3. So finding the mean, median, well, especially the mean will be a lot easier in this case. So the mean for fat would actually just be, right, again, it's sum of the x's divided by n. So in this case, it's 7 zeros, so 7 times 0, 6 ones, so 6 times 1, 1 2, and 1 3. So plus 1 times 2 plus 1 times 3, and then I'm dividing by 15. So that's 6 plus 2 plus 3, so it's 11/15. And then I could get that into decimal form if I wanted to, right? So 11/15 as a decimal is actually 0.73. So I'll say 0.73 grams is the mean grams of fat. And then the median and the mode, I can do the same thing I did before. So again, I remember that the 8th entry is the middle. So there's 7 zeros. So the first 7 are right there. So the 8th one is actually going to be here, right, in 1 gram. So the median is going to be 1 gram. And then the mode is just the one that happens most frequently. And the one with the greatest frequency is actually 0. So the mode is 0 grams. So 0.73 grams for the mean, 1 gram for the median, and 0 grams for the mode. And then the one other piece of info that they have here in this section is this whole idea of a regression line. So what a regression line ends up doing is it really can model data. So if I have like a big set of data here dealing with various amounts of sugar in cereal and how much calories each serving has, I can create a bunch of points, right? So if I'm calling sugar the x coordinate and calories the y coordinate, I have these various points, right? 4, 120, 15, 200, 12, 140, so on and so forth. And what I can do is I can graph those. So I graphed all these points here, and then I can have my calculator or my computer compute what's called the regression line. And it's no different than a regular line that we've dealt with in the past. It's going to be written in this y equals mx plus b form. And what it can be used for is to give predictions, right? And again, this ties into the whole virus bit, right? You take data, and then based on that data, you make predictions. So in this case, it can predict how many calories a cereal would have based on its sugar grams, or vice versa, right? How many sugar grams it would have based on how many calories it has. And you can see that that line there, what it does is it tries to come as close to as many of those points as possible. I mean, it's impossible, obviously, to draw a line through all of them. It's not a straight line, right? They don't form a straight line. So you come up with a line that comes as close as possible to as many of the points as it can. So in the case of this, they're telling you the regression line was y equals 5.137x plus 89.48. And again, x is the grams of sugar and y is the number of calories. So what they could then ask you for is, what is the slope? Well, the slope is 5.137. And if you remember when we did slope as a rate of change, it was always the y units per the x unit. So it's 5.137 y, which is calories, per sugar grams, right? So gram of sugar. So it's 5.137 calories per gram of sugar. So what this means is for each additional gram of sugar in the cereal, you would expect calories to go up by about 5. All right, for each additional gram of sugar, expect calories to increase by 5. And then what's the y-intercept? Well, the y-intercept is the b value, and it was 89.48. And remember what the y-intercept was. It was the value of y when x was 0. So in this case, that means 0 grams of sugar. So what this means is we would expect cereal that has 0 grams of sugar to have 89 calories. And then you can also just use these equations, this equation then, to make predictions. So if I know x equals 5, what could I do? Plug in 5 for x and see what I get for y. So I would just do y equals 5.137 times 5 plus 89.48. Punch that in the calculator. So that would be 115.165. So we'll just say 116. And then you do the same thing for 16 grams. So you do 5.137 times 16 plus 89.48. So with 16 grams of sugar, you can expect 172, let's say, calories. So yes, a lot more calories. So 172 calories. And I should have labeled that calories before, right? So for 5 grams of sugar, you'd expect 116 calories. For 16 grams of sugar, you'd expect 172 calories. Now again, is this exact? No, this is just a prediction, right? So you predict this based on the data that you have.